Welcome back to our Advanced User Interface Technologies course. In today's session, we are going to learn one of the most important concepts in modern web development, client-server communication using the Fetch API in React. So far, we have learned about React components, state management, Redux, and forms. But have you ever wondered how applications like Instagram, Amazon, WhatsApp Web, or Facebook display fresh data every time you open them? Where does the data come from? Is all the information stored inside React? The answer is no. React is mainly responsible for displaying the user interface. The actual data is stored on servers. React communicates with these servers through APIs to retrieve or update information. Today's lecture explains how this communication happens. By the end of this lecture, you will understand how clients communicate with servers, what REST APIs are, how to use the Fetch API, how CRUD operations work, how React applications communicate with backend servers. These concepts are used in almost every real-world React application. Let's quickly look at today's learning objectives. After completing this session, you should be able to understand client-server architecture, explain REST APIs, use the Fetch API inside React, perform CRUD operations, handle asynchronous requests, build React applications, deploy React applications. Notice that these objectives follow the complete life cycle of a web application from requesting data to deploying the finished application. Think of this as moving from development to real world deployment. Client server architecture. Now let's understand the client server architecture. First, what is a client? A client is any device or application that requests information. Examples include Google Chrome, Microsoft Edge, Mozilla Firefox, React application, mobile apps. When you open Amazon.com, your browser becomes the client. The client sends a request asking, "Please show me today's products." Where does this request go? It goes to the server. A server is a computer that processes requests and sends responses. Common backend technologies include Node.js, Express.js, Spring Boot, Django. These frameworks receive requests from users. However, servers usually don't store data permanently. Instead, they communicate with databases. Examples include MySQL, MongoDB, PostgreSQL. Let's understand the complete flow. Imagine online shopping. Suppose you open Amazon, you search for wireless mouse. What happens? You type the product name. React sends an HTTP request to the server. The server checks the database. The database returns matching products. The server converts the information into JSON. React receives the JSON. The products are displayed on your screen. Notice something important. React never directly talks to the database. Instead, React server database server React. This is the standard architecture followed by almost every web application. Let's consider another example. Consider a college student portal. When a student enters the registration number, does React already know the marks? No. React sends a request to the server. The server searches the database. The database returns the student's marks. The server sends the response. Finally, React displays the marks. Every login page, banking application, hospital management system, food delivery application, and e-commerce website follows the same process. HTTP communication. Now that we understand the architecture, let's learn how the client communicates with the server. The communication happens using the HTTP protocol. HTTP stands for Hypertext Transfer Protocol. Think of HTTP as the language spoken between the client and the server. Whenever React communicates, it uses HTTP methods. There are four major HTTP methods. Get, it retrieves the data. Post, it creates a new data. Put, it updates existing information. Delete, it deletes, removes the information. Remember this easy trick. Get, read, post, create, put, update, delete, delete. These four operations are called CRUD operations or CRUD operations. C represents create, R represents read, U represents update, D represents delete. Almost every database application uses this CRUD operations. REST API. Now let's understand REST API. REST stands for Representational State Transfer. Although the name sounds complicated, the idea is actually simple. A REST API is a standardized way for clients and servers to communicate using HTTP. Instead of inventing custom communication methods, developers follow REST conventions. REST APIs have four major characteristics. Stateless. Stateless, each request is independent. The server does not remember previous requests. Every request should contain all necessary information. Second, resource based. Everything is treated as a resource. Third, uses HTTP methods. REST APIs always use get, post, put, and delete method. These methods clearly indicate the requested operation. 4. JSON format. Most REST APIs return JSON. JSON means JavaScript Object Notation. JSON is lightweight, easy to read, and supported by almost every programming language. What is Fetch API? Now comes one of the most important topics. How does React communicate with REST APIs? The answer is through the Fetch API. Fetch is a built-in JavaScript function used to send HTTP requests. Earlier, developers used XML HTTP request. Today, Fetch is preferred because it is promise-based, cleaner, easy to read, supports asynchronous and await, integrated well with React. The simplest fetch syntax is fetch of URL. Here the URL represents the API endpoint. When fetch sends a request, the server processes it, returns a response, and React displays the data. Think of fetch as a courier service. React writes a request, fetch delivers it to the server prepares the response, fetch brings the response back, React displays the information to the user. This communication happens within a fraction of a second. Fetch get request. The most common operation in any application is reading data. Whenever you open Facebook, Instagram, Amazon, YouTube, and Flipkart, the application first loads information from the server. This operation is performed using the GET method. The fetch API syntax is very simple. Fetch of the link, and then the response, and then the data. The fetch function sends a request to the server. The server sends back a response. However, the response is not directly usable. It must first be converted into a JSON format. The response.json function performs this conversion. Now the converted JSON data is available. We simply print it in the browser console. In React, instead of printing it, we usually store it inside a state variable. The complete flow: React application: fetch sends the GET request, server receives request, database returns records, server converts data into JSON, React receives JSON, displays data on the screen. Let's imagine ordering food through Swiggy. You open the app requests nearby restaurants, the server searches its database, the server sends restaurant details, the app displays them. Notice that every time you refresh the app, new information is loaded automatically. This is exactly what the GET request does. Fetch using async and await. The previous example used .thenof function. Although it works perfectly, modern JavaScript provides a cleaner approach called async or await. Async. The keyword async tells the JavaScript that this function performs asynchronous work. This means it may take some time to finish. The await represents the keyword await tells the JavaScript pause here until the server sends the response. Instead of executing the next line immediately, JavaScript patiently waits. Advantages of async or await includes cleaner code, better readability, easier debugging, simpler error handling, more professional coding style. Most companies today prefer async or await over chained .thenof methods. Display data in React. Fetching data is useful only if the users can see it. So, how does React display fetched information? Usually, we use the useEffectOfHook method. UseEffectOf runs automatically after the component loads. It is the perfect place for API calls. SetUsers function. When data arrives, we store it inside the user state variable. React automatically updates the UI. No manual refresh is required. The map function loops through every user. Each user's name is displayed as a list item. Actually, the React immediately displays all the information. No code modification is required. This is why React is called a dynamic UI library. Post request. Now let's create new data. Suppose a student fills an online admission form. When the student clicks submit, the data must be stored in the database. This is done using the post method. The method post tells the server we are creating new data. The header informs the server about the data type. The body contains the actual information. The React converts the object into the JSON using JSON.stringify. The server receives it and stores it inside the database. Finally, the server returns the newly created object. Let's consider a real example: creating new Amazon order, new student registration, new employee record, new customer account. All of these use post requests. Put request. What if we already have data but we want to modify it? For example, a student changes their mobile number, we don't create another student. We update the existing record. That is performed using put method. The flow is existing data, modify the information, put request, finally updated record. The real examples of updating includes user profile, delivery address, employee salary, student marks. All of these use put request. Delete request. Finally, what if we want to remove information? We use the delete method. The method delete supports the server removes the particular student number, that is 5. Real examples of deleting includes shopping cart item, student record, employee information, social media post. All of these uses delete request. So before we get on to the error handling, so the get method is used for reading, the post method is used for creating, the put method is used for updating, the delete method is used for removing. So now you know how React performs all the operations using the fetch API. Let's begin with error handling. Imagine you are using an online banking application. Suppose your internet connection suddenly disconnects while transferring money. What should happen? Should the application simply stop working? No. A good application informs the user that something went wrong. Similarly, React applications should also handle errors properly. A common approach is using the try catch block. An example shows the try block and the catch block. The try block, the code inside the try block executes normally. React sends the request to the server. If everything works correctly, the response is received successfully. The catch block, if something goes wrong, JavaScript immediately jumps to the catch block. The error object contains information about the problem. We can display an error message like unable to connect to the server or please check your internet connection instead of showing a blank screen. The common errors include network failure, server error, invalid URL, and the timeout. Loading state. Now let's improve the user experience. Suppose you search for a movie on Netflix. Does the movie appear instantly? No. For a few seconds you see loading or a spinning animation. This is called the loading state. In React, we usually create a loading state using useState function. This means the application is still waiting for data. Once the server responds, it updates it. The flow represents application starts, loading equal to true, fetching data, data received, loading equal to false, displays the data. The real examples include you can observe loading indicators in Instagram, Amazon, Flipkart, Netflix, Swiggy, and Zomato. Instead of showing an empty page, they display progress indicators. This gives users confidence that the application is still working. React project build process. Now let's assume our application is complete. We have tested every feature. Can we directly upload our source code to the internet? No. React applications must first be built. During development, usually run npm start. This starts the development server. However, for production, we execute npm run build. This command creates an optimized version of our application. React generates a new folder called build. Inside this folder, we find optimized files such as HTML, CSS, JavaScript, images, other assets. These files are compressed and optimized for faster loading. Advantages of build: smaller file size, faster loading, better performance, optimized code, improved security. Every professional React project follows the process before deployment. Deployment process: once the build folder is ready, the next step is deployment. Deployment means making the application available on the internet. The process is simple: develop, test, build, upload, host, users access the website. Popular deployment platforms are Netlify, Vercel, GitHub Pages, Firebase Hosting. These platforms allows us to host React applications easily. So deploy using Netlify. The steps includes account creation, connect with the GitHub, select the repository, build the command npm run build, publish the folder, build, and then click on deploy. Deploy using GitHub Pages. Another popular option is GitHub Pages. Install npm install ghpages, add the homepage field inside package.json, add scripts for pre-deploy and deploy, execute npm run deploy. GitHub automatically publishes your website. Students commonly use GitHub Pages to host mini projects and portfolios. Now let's discuss some best practices followed by professional React developers. Always use HTTPs. HTTPs encrypts communication between the client and the server. Never use HTTP for sensitive applications. Handle errors properly. Always display meaningful error messages. Never leave users confused. Validate user input. Check user input before sending it to the server. Store API URLs in environment variables. Instead of writing URLs directly inside components, store them in environment variables. This makes the maintenance easier. Create reusable API functions. Instead of repeating fetch code everywhere, create reusable functions. This improves the code organization. Show loading indicators. Always inform users while data is being loaded. It significantly improves the user experience. Responsive user interface. Ensure the application works properly on desktop, tablet, and mobile. Most users today access websites through smartphones. Secure API keys. Never expose API keys directly in your source code. Keep them private using environmental variables. This is an important point to be noted while securing API keys. Let's quickly summarize today's lecture. Today we learned client-server architecture, HTTP communication, REST APIs, fetch API, GET request, POST request, PUT request, DELETE request, async or await, error handling, loading state, React build process, deployment using Netlify and GitHub Pages, best practices for React development. Now you understand the complete journey of a React application from requesting data from a server to deploying the finished application on the internet. These concepts are not only important for the React application, but also the fundamental skills expected from React developers for the real world application development. Thank you for watching this lecture. Happy coding!